Hello and welcome to 2-3, real zeros of a polynomial function. We're going to talk today about finding the real zeros and checking to see if various equations can go into other equations. This is one of my favorite topics of the entire year. I absolutely love this. We're going to deal today primarily with division of algebraic expressions by other algebraic expressions. We're going to begin with long division. So divide, we're going to divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. And then we will use the result to factor the polynomial completely. What we're basically going to do here is we're going to divide out a certain factor so that we can get to a more simple factor and then solve out our problem. Because right now it does not look very nice to factor. But let's go ahead and do some division. So x minus 2 into 6x cubed minus 19x squared plus 16x minus 4. Now, what I want to do every step of the way is I want to find and put up here some item, combination of letters and numbers, that when multiplied by this will become this exactly by the first term. So if I have 6x squared and I multiply it by x minus 2, I get 6x cubed minus 12x squared. Now what I'm going to do is I'm going to subtract that entire term away. 6 minus 6 is 0. Now, negative 19 minus negative 12 becomes negative 19 plus 12, which gives me negative 7x squared. Okay, now I want something that times x will give me negative 7x squared. So I'm going to go minus 7x. Multiply it through, I get negative 7x squared. I'm also going to bring this term down. And I'm going to multiply it through and get positive 14x. Now, I'm going to subtract away that term. By subtracting it away, by making it identical first, then when I subtract it, the subtraction basically flips the signs on everything inside the parentheses. So my x squareds will cancel out, and I will get 2x, because 16 minus positive 14 is 2. So now, x times what will be 2x? Well, by positive 2. So now I'm going to bring down my negative 4. 2 times x is 2x. 2 times negative 2 is negative 4. And when I subtract that away, I get 0 and I have nothing remaining. So now I can rewrite this as x minus 2 times 6x squared minus 7x plus 2. Now I need to factor this, which will be 2x minus 1 times 3x minus 2. And I factor that just by eyeballing it. Now what we're going to teach you today is that you could end up using this method to also test factors when you have higher order polynomials to factor it out. The division algorithm states that if f of x and d of x are polynomials such that d of x does not equal 0, and the degree of d of x is less than or equal to the degree of f of x, then there exist unique polynomials q of x and r of x such that the dividend f of x equals the divisor d of x times the quotient q of x plus the remainder r of x. So pause to write that down. But up here, then this was the original function. Okay? By our definitions, this was the divisor, and what was on top was the quotient. And this was the remainder. So let's divide x cubed minus 1 by x minus 1. So I'm going to say x minus 1, but I notice I skip all the way from x cubed down to 1. So I'm going to put in here a 0x squared and a 0x and then minus 1. It's important that I do that so that way I keep organized. So what times x gives me x cubed? X squared does. So I'll have x cubed minus x squared. Subtract that. Remember, it changes the sign. The negative distributes to everything. So I'll have x squared, and I'll bring down 0x. Now I'm going to see what times x is x squared. Well, I'll have x. I will multiply it through to get x squared minus x. When I subtract that, once again, I get my 0 here, my 0 here, and now I get x minus 1. And, well, that's a simple one. I can just multiply it by 1. And I get x minus 1, and when I subtract that out, I get a remainder of 0. So the original function was x cubed minus 1. The divisor was x minus 1. The quotient is x squared plus x plus 1. And the remainder is 0. So a more complicated long division. Well, this should be fun. Let's take a look at it. So we have x squared plus 2x minus 3 into, now my highest power, I'm going to put them in order. So it's 2x to the 4th. I have 0 x cubed. I have negative 5x squared plus 3x minus 2. All right, so now I just have to start doing some basic math. What times x squared is 2x to the 4th? It is 2x squared. So now I'll have 2x to the 4th plus 4x cubed minus 6x squared. Subtract each of those away, and I get negative 4x cubed plus x squared. Remember, this negative, this minus gets distributed to every term, and it basically changes the sign. So it becomes 2 minus 2, 0 minus 4, negative 5 plus 6. And I bring down my next term. So what times x is negative 4x cubed? It'll be negative 4x. So I'll get negative 4x cubed. Remember, I just want to match up the first term with the other first term. Everything else at the end, I just let it take care of itself. Negative 4x times positive 2x gives me negative 8x squared and plus 12x. Change my sign. These will cancel out. I always forget to put that 0, but you can. X minus negative 8x squared will give me 9x squared, and 3 minus 12 gives you negative 9x. Now I'm going to bring down my negative 2. All right, I need plus 9. So we're going to multiply by 9 because I've got 9x squared. So I'll have 9x squared, and then I'll have plus 18x, and I'll have minus 27. Okay? Those will take care of themselves. Negative 9 minus 18 is negative 27x, and negative 2 plus 27, because it will be negative 2 minus negative 27, gives you negative 25. So basically, I have a remainder So if I were to rewrite it in the original thing, I could say that 2x to the fourth minus 5x squared plus 3x minus 2 equals x squared times 2x minus 3, x squared plus 2x minus 3 times 2x squared minus 4x plus 9 plus negative 27x minus 25. If we were to rewrite it in the phraseology by the first one, by that first box. Now, synthetic division is, some people like synthetic, some people like long, some people hate both, some people love both. Synthetic division allows you to simply do numbers and drop your letters. So here's what happens. You identify every coefficient in front of everything. If it's missing it, you put in a 0. Now, in this case, we are dividing by some term that is we're finding whether or not something is a solution. So it'll be x minus that number. We take that number and we create a synthetic division problem such that we bring down the first one, multiply here to get there, and then keep going. So for our vertical pattern, we add terms, and then for each one we multiply by k. Observe, and I will demonstrate here. So if I have x to the fourth minus plus 0x cubed minus 10x squared minus 2x plus 4, and I'm going to divide it by x plus 3. My terms here are 1, 0, negative 10, negative 2, and positive 4. So in this case, if x plus 3 equals 0, then x will equal negative 3. And I'm going to write my terms. So my instructions. I add terms. I've got nothing to add to, so it's just 1. I multiply that number at the bottom by negative 3. So I'll get negative 3. I then add my terms to get negative 3. Multiply it always by k to get positive 9. So let me slow down here. I took my 1 and I dropped it straight down because there was nothing to add it to. I multiplied it by k to get negative 3 because negative 3 times 1 is negative 3. I added it to whatever the top number is, and it was negative 3. Negative 3 times negative 3 is positive 9. Now I'm going to add. I get negative 1. Negative 3 times negative 1 is positive 3. I add, and I get positive 1. I multiply, and I get negative 3. I add, and I get 1, and whatever is the last number is my remainder. So when I divide it by x plus 3, I get x cubed minus 3x squared minus x plus 1, and I will have a remainder of 1 over x plus 3. Whatever my remainder is, I can put it over my original divisor of x plus 3. Now, if you had gotten a remainder of 0, that would mean it's a factor. So the remainder theorem states that if polynomial f of x is divided by x minus k, then the remainder is that r equals f of k. So in other words, by doing the remainder theorem, what we said on this last problem, per the remainder theorem, that at x equals negative 3, y equaled 1. So it's another way that you can evaluate in a polynomial to find what y equals at a certain term. So use the remainder theorem to evaluate the function at x equals negative 2. So I'm going to have negative 2, and then I'm going to write in my stuff. So I've got 3x cubed, 8x squared, 5x, and negative 7. I have no missing terms, so I don't have to add in any zeros. I follow my pattern. Add down, multiply by k up. Add down, multiply by k up. Add down, multiply by k up. Add down, and that is my remainder. So what that means is that when x equals negative 2, y at that function equals negative 9. It makes it a very simple method, even simpler than plugging it in, because I would have had to plug it in and go 3 times negative 2 squared plus 8 times negative, or 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. But by using synthetic division, I can quickly plug it into the problem, and because of the remainder theorem, it tells me that, boom, that's what y equals at that number. All right, and that concludes today's lesson.